Hi, I'm Sean Ganem, and this is Minute Math, and today we're learning about excluded values.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, 30k minus 20 over 90k, and we want to state the excluded value. Well, the main thing I'm looking at here is, well, this is a rational function, meaning the denominator cannot equal 0. So I'm going to take that denominator, 90k, and I'm going to set it equal to 0 and solve for k here. Well, 90 times k is, well, opposite is multiplication, right? So opposite of that's division, so we divide both sides by 90. This gives us a value, well, k equals 0 divided by 90 is just 0. And so 0 is our excluded value. We're given this problem right here, 16 over 6n minus 2, and we want to state the excluded value here. Well, one thing we know is that we're not allowed to divide by 0. So we need to take this expression and look at the denominator, 6n minus 2, and we're going to set it equal to 0. With that, we're going to solve for n, the value that makes the denominator equal to 0. I add a 2 to both sides, and I have 6n equals a positive 2. Divide both sides by 6, and n equals, well, 2 divided by 6 simplifies to be 1/3. And so 1/3 is the value, or is our excluded value. We're given this problem right here, 18 divided by 27x plus 27, and we want to state the excluded value. The excluded value here is when the denominator is equal to 0 because we can't divide by 0. So we need to take that denominator, 27x plus 27, and we're going to set it equal to 0. And now we're going to solve for x. Subtract 27 to both sides, and 27x equals a negative 27. Divide both sides by 27, and x equals, well, negative 27 divided by 27 is a negative 1. And so negative 1 is our excluded value. We're given this problem right here, 35v minus 63 divided by 63. And we want to state the excluded value. Well, excluded value is a value that we cannot plug into this expression. And normally that happens here with a rational function when we're dividing by 0. So normally I would take my denominator, 63, and I'm going to set it equal to 0. But now we have an issue. There's no variable here. There's no way that this denominator, right, can equal 0. So in that case here, there are no excluded values. And so that is our final answer. We're given this problem right here, p squared minus 18p plus 81 over p minus 9, and we want to find the excluded value. Well, this is a rational function, and it doesn't exist when we divide by 0. So when 0 is in the denominator, that's our excluded value. So we're going to take our denominator, p minus 9, and I'm going to set it equal to 0. Now I'm going to solve for p. I add a 9 to both sides, pretty simple, and p equals, well, a positive 9. And so that's it. 9 is our excluded value. We're given this problem right here, 4x squared divided by 14x squared minus 16x, and we need to state the excluded value. We first look at our denominator here, 14x squared minus 16x. We know we cannot divide by 0. So we're going to take that denominator, 14x squared, I can write it squared, minus 16x, and we're going to set it equal to 0 to find the x values that make the denominator equal to 0. I can pull out an x here, it's in both parts, and we have 14x minus 16 equals 0. Now since that's multiplication, we can set both parts equal to 0. So x equals 0, and 14x minus 16 equals 0. We're going to solve for x here, so we add a 16 to both sides. 14x equals a positive 16, And then I'm going to divide by 14 to both sides. And x equals, well, 16 divided by 14 simplifies to be 8/7. And so our two x values here, our excluded values, are x equals 0 and 8/7. And so there are our excluded values. We're given this problem right here, a squared minus 10a plus 25 over 5 minus a, and we want to find the excluded values. Well, I know with rational functions we can't divide by 0. So if we find the value of a that makes the denominator equal to 0, that's our excluded value. So we take our denominator, 5 minus a, and I'm going to set it equal to 0. Now I'm going to solve for a. I subtract a 5 to both sides, and I have a negative a equals a negative 5. Okay. Divide both sides by a negative 1. The negatives cancel, and we have a now by itself. Negative 5 divided by negative 1 is a positive 5, and so positive 5 is our excluded value. We're given this problem right here, 45r minus 72 divided by 27r, and we want to find the excluded value. We have a rational function here, and we know we cannot divide by 0. So we're trying to find the r value that makes the denominator equal to 0. So we take our denominator, 27r, and we're going to set it equal to 0. And now we're going to solve for r. We divide both sides by 27 because opposite of multiplication is division. 27's cancel, and we have r by itself. Now be careful here. What's 0 divided by 27? And that is just 0. So there we have it. 0 is our excluded value. We're given this problem right here, 81 divided by 27n minus 54, and we want to state the excluded values. Again, we have a rational function right here, and we know we cannot divide by 0. So we have to take our denominator, 27n minus 54, and find when this denominator is equal to 0. So now we're going to solve for n. We have to add a 54 to both sides. Not too bad. And so we have 27n equals a positive 54. Now we divide both sides by 27, opposite of multiplication is division, and 27's cancel, leaving us with n by itself. 54 divided by 27 is 2, and so there we have it. 2 is our excluded value. We're given this problem right here, x squared plus 3x minus 70 over x plus 10, and we want to find the excluded value. Well, we know we cannot divide by 0, so we're trying to find here the value in which, for x, for the denominator is equal to 0. So we take our denominator, x plus 10, and we're going to set it equal to 0. Now we're going to solve for x. Pretty simple now. Subtract a 10 to both sides, and x equals, well, a negative 10. So that's it. Negative 10 is our excluded value. We're given this problem right here, x squared minus 5x plus 6 divided by x minus 2, and we want to state the excluded value. Well, we have a rational function here, and we know with rational functions, right, we cannot divide by 0, so we can't have a 0 in the denominator. So we take our denominator, x minus 2, and we set it equal to 0. Now we have to solve for x. Not too hard. We add a 2 to both sides, and it's pretty simple. X equals, well, a positive 2, and that's it. That's our excluded value. We're given this problem right here, 10n minus 20 over 20n, and we want to state the excluded values. Well, we look at our denominator here, and we know that we cannot divide by 0. So I'm going to take that denominator, 20n, and I'm going to find when it's equal to 0. Well, this isn't too hard now. Multiplication is going on, 20 times n. Opposite of that is division. Divide both sides by 20. 20 cancels out on the left-hand side, n is by itself. And 0 divided by 20, be careful here, is just 0. And so there we have it. 0 is our excluded value. We're given this, well, expression right here, x squared minus 11x plus 30 over x minus 6, and we need to state the excluded value. Well, we know we cannot divide by 0, so we know we can't have a 0 in the denominator. So we need to take that denominator, 6 minus x, and I'm going to set it equal to 0 to find the value where, well, x equals 0. Okay, well, let's subtract a 6 to both sides here, and we have negative x equals a negative 6. I then can divide both sides by negative 1 to get rid of the negative sign, and we have a positive x equals a negative divided by negative is a positive, so we have positive 6 right here. And so there we have it. 6 is our excluded value. We're given this problem right here, 40k plus 24 over 40k plus 48, and we need to state the excluded values. Well, we know we cannot divide by 0, so if 0 is in the denominator, there's our excluded value. So we take our denominator, 40k plus 48, and we're going to set it equal to 0 to find the k value that causes the denominator to equal 0. So let's solve for k. Subtract a 48 to both sides. Fairly simple so far. And 40k equals a negative 48. We then divide both sides by 40 here, and k is now by itself. Negative 48 divided by 40 simplifies to be negative 6/5. And so there we have it. Negative 6/5 is our excluded value. We're given this problem right here, x squared plus x minus 72 over 10x plus 90, and we need to state the excluded values. Well, we're dividing here, or we have a rational function, right? And we know we cannot divide by 0. So our denominator, if it's equal to 0, that's where we're finding our excluded value. So I take my denominator, 10x plus 90, and I'm going to set it equal to 0. Now we're going to find the x value that makes this happen. We subtract a 90 to both sides, and we have 10x equals a negative 90. Divide now both sides by 10, fairly simple, and x equals negative 90 divided by 10, which is a negative 9. So negative 9 is when, for the x value, we plug in the denominator, is where the denominator equals to 0. So negative 9 is our excluded value. We're given this problem right here, x squared minus 2x minus 63, divided by x squared plus 5x minus 14, and we need to state the excluded value. Well, we have a rational function, and we know with fractions here, well, or division, we cannot divide by 0. So if our denominator is equal to 0, there we have our excluded value. So we're going to take our denominator, x squared plus 5x minus 14, and we're going to set it equal to 0. Now we're going to solve for x. Well, this looks like it can factor fairly easily. We have an x here and an x here. What two numbers multiply to be negative 14, but add to be a positive 5? That's a 7 and a negative 2. 7 times negative 2, negative 14. We add the 2, we got a positive 5. Now that it's in this form, we can set both parts equal to 0 to solve. We subtract a 7 to both sides here, and x equals a negative 7. We add a 2 to both sides on this one, and x equals a positive 2. And so negative 7 and a positive 2 are our excluded values. We're given this problem right here, n squared plus 11n plus 18 divided by n squared plus 8n minus 9, and we need to state the excluded values. Well, I see division going on here. It's a rational function, and we know we cannot divide by 0. So if 0 is in the denominator, that is a big no-no. So we're going to take our denominator then, n squared plus 8n minus 9, and we're going to find when it's equal to 0. Okay, well, this looks now like something that we can factor. I know, you probably don't like factoring, but it's okay. We ask ourselves what two numbers multiply to be negative 9, but add to be a positive 8. And that's a positive 9 and a negative 1. 9 times negative 1, negative 9. Add the 2, positive 8. Now that it's in this form, we can set both parts equal to 0. And now we're solving. Subtract a 9 to both sides, fairly easy. N equals a negative 9. Add a 1 to both sides, n equals a positive 1. So n equals negative 9 and a positive 1, and those two are our excluded values. We're given this problem right here, 15n plus 5 over 10n plus 10, and we want to find the excluded values. Well, this is a rational function right here, and we're dividing. We know we cannot divide by 0 though. So when this denominator is equal to 0, we can't do that. So let's go find those values. So 10n plus 10, the denominator, I'm going to set equal to 0. Now I'm going to solve for n. I subtracted 10 to both sides, and we have 10n here is equal to, well, negative 10. Divide both sides by a positive 10, and we're pretty much there. And negative 10 divided by a positive 10 is a negative 1. So there we have it. Negative 1 is our excluded value. We're given this problem right here. 15x squared plus 50x divided by 15x squared plus 30x, and we need to state the excluded values. Well, this is a rational function, and we know we cannot divide by 0. So we take this denominator, and we're trying to find when it's equal to 0. We take 15x squared plus 30x, the denominator, and we're going to set it equal to 0 here. Okay. Well, we see there's an x in both parts. So if I pull that out, I'm left with x times 15x plus 30. Now we can set both of these equal to 0 and solve. So x equals 0, pretty easy, and 15x plus 30 equal to 0. Now we have to subtract, well, 30 to both sides, and we have 15x equals a negative 30. Divide both sides by 15, and x equals negative 30 divided by 15 is a negative 2. And so our two values here are 0 and negative 2, and that's it. They are our excluded values. We're given this problem right here, 25p squared minus 5p divided by 15p squared plus 45p, and we want to state the excluded values. Well, we have a rational function, and we know we cannot divide by 0. So when the denominator is equal to 0, there's our excluded values. So we take the denominator, 15p squared plus 45p, and we're going to set that equal to 0. Now we're going to solve for p. Well, there's a p in both parts here. So if I pull out a p, I'm left with a 15p here plus 45 equals 0. Now we have multiplication, so we can set both of these equal to 0. P equals 0, not too bad. 15p plus 45 equals 0. Solving for p here, subtract a 45 to both sides. 15p equals a negative 45. Divide both sides by, well, 15. And p equals negative 45 divided by 15 is a negative 3. And so our two excluded values are 0 and a negative 3, and that's our final answer. We're given this problem right here, 2r to the third power minus 10r squared minus 12r divided by r squared minus 8r plus 12, and we want to find the excluded values. Well, we have a rational function here, or a rational expression, and we know we cannot divide by 0. So when this denominator is equal to 0, that's our issue. So we're going to take the denominator, r squared minus 8r plus 12, and we're going to set it equal to 0 here. Now, this looks like it factors fairly well. What two numbers multiply to be positive 12, but add to be a negative 8? A negative 2 and a negative 6. Negative 2 times negative 6 is a positive 12. We add the 2, we get negative 8. So now we have two parts equal to 0. We can set each part individually equal to 0. Now we're solving. We add a 2 to both sides, and r equals a positive 2. Add a 6 to both sides, and r equals a positive 6. And so our two excluded values are just 2 and 6. We're given this problem right here. 2x squared minus 24x plus 70 over 2x to the third power minus 20x squared plus 50x. And we want to find the excluded values. Well, we know this is a rational expression here, and we cannot divide by 0. So when 0 is in the denominator, there's our issue. So we're going to take the denominator, 2x to the third power minus 20x squared plus 50x, and we're going to find when that is equal to 0. Well, notice there's a 2 in all parts here as well as an x. So I'm going to simplify that and pull out a 2x. What am I left over with? X squared minus 10x plus 25. So now that's being multiplied here. But notice this part here, x squared minus 10x plus 25. That looks like it can factor fairly easily. So what two numbers multiply to be positive 25 but add to be negative 10? And that's a negative 5 and a negative 5. So now we have it in factored form. We can set all parts equal to 0. 2x equals 0, x minus 5 equals 0, and x minus 5 again equals 0. Let's be careful with that. So now we're going to solve for x. Divide by 2, and x equals 0. Be careful, 0 divided by 2 is 0. Add a 5 to both sides here, and x equals a positive 5. Do the same thing again, and x again equals 5. So be careful here. When we have a repetition of the same exact number, we don't need to write it twice. So x equals 0 and 5 are our two excluded values. We're given this problem right here. 15p squared minus 24p divided by 21p to the third power plus 33p squared plus 12p. And we want to find the excluded values. We know we have a rational expression here, and we know we cannot divide by 0. So we need to find when the denominator is equal to 0. So we take the denominator, 21p to the third power, plus 33p squared, plus 12p, and we're going to set it equal to 0. To find the p-values that make this equal to 0. Well, let's simplify this a little bit. Let's pull something out. A 3 goes into all parts, and there's a p in all parts as well. So if we pull out a 3p, we're left with a 7p squared plus 11p plus 4, and that's equal to 0. Okay? Well, this inside part now looks like it can factor fairly easily. So 7p squared plus 11p plus 4, we know it has some form like this, and we have to figure out what goes on the inside. Well, that ends up being a positive 4. Positive 4 and a positive 1. 4 times 1 is positive 4. We're good. 7p times 1 is 7p, plus 4 times p is 4p. We add them together, we get 11p. And then 7p times p is 7p squared. Alright, now we have it in factored form. We can set each part equal to 0 and solve. 3p equals 0, 7p plus 4 equals 0, and p plus 1 equals 0. Divide 3 to both sides, and p equals 0. Be careful there. Subtract a 4 to both sides here. We have 7p equal to negative 4. Divide both sides by 7, and p equals a negative 4 sevenths. Here we're going to subtract 1 to both sides, and p equals a negative 1. And so our three values here are just 0, negative 4 sevenths, and negative 1, and those are the three values that are our excluded values. We're given this problem right here, 7x squared plus 28x divided by 2x squared plus 6x minus 8, and we want to find the excluded values. Well, we have a rational expression here, and we know we cannot divide by 0. So we have to find when this denominator is equal to 0. 2x squared plus 6x minus 8 is equal to 0. Okay? So now, where do we go from here? We want to solve for x. Well, notice there's a 2 actually in all parts. So if I divide 2 to everything on both sides of the equation here, cross. We're left with x squared plus 3x minus 4 equals 0. So now this looks like actually something that's easy to factor. We have x right here, x, we have our form. And what two numbers multiply to be a negative 4, but add to be a positive 3? And that's, well, a positive 4 and a negative 1. 4 times negative 1, negative 4. 4 plus a negative 1 is a positive 3. Now that it's factored, we can set both parts equal to 0 and solve. Subtract a 4 to both sides, and x equals a negative 4. Add a 1 to both sides, and x equals a positive 1. So we have x equals negative 4 and positive 1. You can write it as one statement. X equals negative 4 and positive 1. And those are our excluded values. We're given this problem right here. 2r squared plus 4r minus 70 divided by r to the third power minus r squared minus 49r plus 49. And we want to find the excluded values. We have a rational expression right here. And we know we cannot divide by 0. So we're going to take our denominator, r to the third power minus r squared minus 49r plus 49, and we're going to find when this equals 0, what r values cause that to happen. Well, I see I can actually factor this by grouping. I'm going to pull out an r squared here, and I'm left with, well, r minus 1 from this, just these two right here. Then, plus, I'm going to do plus and negative. I'm going to pull out a negative 49 here from both parts. So we have negative 49, and we're left with, well, r minus 1. So we have negative 49 times r minus 1 here is equal to, well, what we wrote up there. Notice an r minus 1 now in both parts. If I pull that out, I have an r minus 1 here, and I'm left with that r squared plus a negative, well, 49. And that's equal to 0. So now I have this in factored form, and, well, I can solve by setting each part individually equal to 0. So r minus 1 equals 0, and r squared here I'll write it as minus 49 equal to 0. Add a 1 to both sides, pretty easy, r equals positive 1. Add a 49 to both sides, and r squared equals a positive 49. Take the square root. R equals plus or minus square root of 49, which is 7. And so there we have our three values of 1, negative 7, and positive 7. And those three are our excluded values. We're given this problem right here. 2a plus 4 divided by 3a to the third power minus 3a squared minus 18a. And we want to find the excluded values. We have a rational expression right here, and we know we cannot divide by 0. So, if we can find when the denominator is equal to 0, we can find our excluded values. So we take the denominator, 3a to the third power minus 3a squared minus 18a, and we're going to find when it's equal to 0. Okay? Well, notice I see a 3 as in all parts here, as well as an a. So if I pull out a 3a, I'm left with a squared minus a minus 6 equal to 0. So now we have 3a times a squared minus a minus 6, and that's equal to 0. Well, this inside part looks like it factors fairly easily. What two numbers multiply to be negative 6, but add to be a negative 1? That's a positive 2 and a negative 3. 2 times negative 3 is a negative 6. 2 plus a negative 3, negative 1. So now we have it in factored form. We can set all parts equal to 0. So we have 3a equals 0, a plus 2 equals 0, and a minus 3 equal to 0. And now we're going to solve for a. Divide both sides by 3, and a equals, be careful here, 0 divided by 3, 0. Subtract a 2 to both sides, and a equals a negative 2. Add a 3 to both sides, and a equals a positive 3. And so we can write this as one statement. A is equal to 0, negative 2, and positive 3. And those are our excluded values. I hope this video was helpful, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.